Okay, here's a learning target for today. You can evaluate outputs given inputs. You can evaluate inputs given outputs. You can identify one-to-one functions, and you can perform operations of functions. Okay, so let's first talk about what is a one-to-one function. So a one-to-one function is a function, okay, and for every output, there is only one input. So if we compare that to the definition of function, which is for every one input, there's only one output. This time we're saying for every one y value, oh, that's supposed to be a y. There we go. There's only one x value, okay? So what does this look like? Let's draw a mapping diagram. Let's just have 1, 2, 3, then 4, 5, 6. Okay, so let's say 1 maps to 4, okay? 2 maps to 5, and 3 maps to 6. 4 only has one input. 5 only has one input. 6 only has one input. So this is a one-to-one function. Okay, here's how it would look like for a graph. Okay, all these points here on this line, they only have, for every output, they only have one input. So what does it not look like? Okay, well, the best example of a graph is going to be a parabola. Because as you can see here, this output right here, let's say it's 3, it has 2 inputs here and here. So a parabola, a quadratic, is an example of something that's not one-to-one. Okay, for a mapping diagram, if I drew 1, 2, 3, and 2 to 3, that would not be one-to-one. So let's figure out if these examples are one-to-one. Okay. So it says determine if the following are one-to-one. So in this first one, we can tell that this parabola is not one-to-one. For functions, we have the vertical line test. For one-to-one, we're going to have the horizontal line test. Okay. So for this parabola, if I draw a horizontal line, you'll see it'll cross here and it'll cross here. Okay. So this is not one-to-one. For the second one, I gave you a function, but you can tell that it's I gave you an equation. You can tell that it's a parabola, so it's also going to be not one-to-one. Oops. Okay, and this last one, okay? If you look here, you can see that it crosses twice. It fails the horizontal line test. So this one is also not one-to-one. Okay, cool. So let's talk about function notation. So we already introduced this the other day, okay? And it says function notation is a way that a function is written. It is meant to be a precise way of giving information about the function without a rather lengthy written explanation. Okay? So the way we read this symbol here, f parentheses x parentheses, is f of x. Okay? X is your input, and then the entire expression is your output. So let's look down here. Number 1 says, if f of x equals 3x cubed minus 9x squared, g of x equals 3x, and h of x equals 6x cubed minus 10x squared plus 4x, find the following. And the first one we want to find is f of negative 1. So we did this the other day for the starter, okay? We're going to take negative 1, and we're going to be plugging it into the function for x. okay? Negative 1 squared, or sorry, negative 1 cubed is negative 1, and negative 1 times 3 is negative 3. Negative 1 squared is positive 1, so we're left with negative 9. So this is going to be negative 12. So f of negative 1 equals negative 12. So that's our answer. We can plug more than just numbers in. We can plug expressions in. So look at g. G says g of 10 minus x. So I'm going to take that expression, 10 minus x, and plug it in for 3. Or plug it in for x, meaning I'm going to multiply it by 3. So I'll distribute. So this is going to be 30 minus 3x. So this equals 30 minus 3x. So that would be our answer. Okay. So take a second and think, what if I asked you to find f plus h of x? Well, what we're going to do here, okay, is we are going to, what this is saying, it's saying, hey, let's take h or f of x plus h of x. These are the same notation. And so it's saying, hey, add together f and add together, or combine like terms with f and h. So f is going to be 3x cubed minus 9x squared. And then h, I'm going to put parentheses around my functions, my expressions, my polynomials. 6x cubed minus 10x squared plus 4x. And I'm going to add like terms, okay? And we did this with the imaginary numbers, where we added like terms, where we multiplied expressions, added expressions, all that stuff. So the same rules apply. Okay, I like to underline. So this is going to be 9x cubed, negative 19x squared, and then just plus 4x. So this would be our answer. And if you look here, it says we can add, subtract, multiply, and divide functions. The result is a new function with a potentially new domain. Okay, it might lead us to a new domain. Okay, so we go down here. Okay, we already did A. We already did this one. We have B, where we're going to divide. So let's divide. We have g over f of x. So I'm going to take g, which is 3x, and I'm going to divide over 3x cubed minus 9x squared. So you really want to be careful about how we do this, because all we can do right now is simplify using factoring, okay? In this case, we have a greatest common factor in the denominator. It looks like our denominator has a greatest common factor of 3x squared. So I'm going to take out a 3x squared. Okay, what's left over? X minus 3. Well, the 3's are going to cancel. And this x up here will cancel, and we'll left with 1x here. So we'll have a 1 in the numerator. And we'll have x times x minus 3. And you can just go ahead and leave it like that. And that would be our answer. So be really careful when you divide. Okay? I want you to pause this video, and I want you to do number 3. When you're done, unpause it. I'll have my answers on the screen. Okay, these are the answers that I got for A, B, and C. So for A, I added f and g together. There weren't any like terms, so I just wrote them as one expression. For B, I multiplied g by h, so I distributed it. And there's my expression right there, 5x to the 4th minus 10x cubed plus 10x. And then for C, I divided f over g, and since g is a monomial, I can actually splitsville it and break it up. So 25x to the 5th over 5x, 10x squared over 5x, and I simplified those, and that's my answer. Okay. So those were expressions. We were inputting expressions, but how about if we input numbers now? Okay, so let's look at number 4. Let me zoom in here. Okay, so we have two functions. We have f of t equals 3t plus 1, and g of t equals 2t minus 3. And it says find 2 times f of 10 minus g of 10. So it's saying I want to insert 10 into f. I want to insert 10 into g. I want to multiply 2 by f of 10 and then subtract the 2. Okay? So let's do f of 10 is going to be 3 times 10 plus 1. So this is going to be 31, but then we have to multiply it by 2, right? So this is going to be 62. And then we need to take 10 and plug it into g. So g of 10 is going to be 2 times 10 minus 3. So this is going to be 20 minus 3, so this is going to be 17. And we are subtracting those two. And we subtract them, we get 45. So in this case, we got a single number, but in the examples above, we had expressions as the answer, which is totally fine. Okay, last little bit of this video. So let me erase this. So in number 5, it says if f of x equals 4 and f of x equals equals 100 minus 3x, what is the value of x? So this question is saying, hey, I know the output. I know f of x is 4. And I have the function, f of x equals 100 minus 3x. But I'm trying to figure out the value of x. I'm trying to figure out what did I plug in for x to get 4. So what we can do is we can set this equal to 4 and do 4 equals 100 minus 3x and then solve for x. So I'm going to subtract the 100 over. Minus 96 equals negative 3. And then you want to divide that 3 over, which is going to be 32. Negative 3 over, sorry. Divide the negative 3 over. So x equals 32. And to check your work, you find f of 32. Oops. There we go. So it'd be 100 minus 3 times 32. Okay, and that should be 4. Well, 3 times 32 is 96, and 9 minus 96 is 4. So that's our answer. Perfect. Okay, you may begin to work on your homework. Bye, everybody.